So how do you find the linear equation given the value of the slope and the y-intercept? Let's go back to this particular example. If you try to recall, this was our formative a week ago. You're given this graph, and part of the question was for you to find the rate of car rental in this particular graph. So some of you were able to get it right, while majority wasn't able to get it. So for those who were able to get it right, the rate of car rental here is an increase of $5 every 10 miles. Now, this is actually the slope or the rate of change. This tells us how the cost, which is your y, in dollars changes every time your x changes as well. Remember, the change in the y per unit change in x is simply your slope. Now, since we already discussed on slope, this time 5 per 10 miles is not anymore accepted as the simplified form. So we have to simplify it further, thus the slope would be 1 half. 1 half means car rental cost increases by $1 every 2 miles. Now, here, y-intercept is $63. Again, we already discussed what y-intercept is. This means that this is the amount to pay before travel begins. Now, try to recall, how would you compute for the total cost if you know the miles driven? This is also one of the questions during the formative, by which only a few were able to get it right. So I'd like you to think over right now. You may pause this video and try to think, give yourself a minute or two to think it over again. If you know that the miles driven is 20, considering that this is the slope and this is the y-intercept. So you started with 63. Even before driving, you are now to pay 63. And then the car rental cost increases by $1 every 2 miles. So how will you determine the total cost or the total amount to pay if you have driven 20 miles? Give yourself some time. All right? So if you try to recall our answer to this, it's actually equal to y equal to 1 half x plus 63. In other words, the total cost will just be half of the number of miles driven plus 63. So if the question a while ago was 20, for instance, half of 20 is 10. 10 plus 63 is 73. If you try to look at the graph, indeed it's 73. So having driven 20 miles, it costs you to $73. All right. Now, right now, it might be quite difficult for you, or you might be puzzled. How were we able to come up with this particular equation? By the way, we call it the linear equation. This equation somehow describes a linear relationship relating the two quantities x independent and y dependent. Now, to answer that particular question of how to be able to come up with this, there is actually a certain form which is now shown here. So if you observe clearly, this 1 half is just simply your slope, and this 63 is simply your y-intercept. In other words, if you try to look at this format, this is simply y equals whatever the slope is times the x plus the y-intercept. In other words, to form a linear equation, it is simply using this particular form, wherein the dependent quantity y will just be equal to your slope times the independent quantity x plus y-intercept. Now, since it's very long to write the word slope and y-intercept, we can just represent them with variables. And internationally or universally, the variables we are using are m and c. M for the slope and c for the y-intercept. So you have to get used to using these variables m and c. M to represent the slope and c the y-intercept. All right? We call this the slope intercept form because we're using the slope and the y-intercept to build the linear equation. And what's good about having a linear equation, it's easy for you to find data even beyond the graph, the given graph. This graph is only showing up until 40, but with the equation, you can go beyond 40. You can go 100. You can go 200 miles. Or even you can go beyond $84. You can go $100, $120. To give you a sample, suppose we are looking into 20 miles, as what I've told you a while ago. So if we know now the equation, we can just simply substitute x by 20. Remember, this is the x-axis. 20 miles is the independent quantity, thus it should be substituted in the x. So substitute 20 to x. So half of 20 is 10. 10 plus 63 is 73. Also, if you're given the total cost, say 68, and if you're looking for the number of miles driven for this total cost, you could still do the same thing. But this 68 should be substituted to the y because this is in the y-axis, or this is the dependent quantity's value. So this would now be 68 equal to half x plus 63. This time, we're now looking for the number of miles driven if the total cost is 68. So doing a little algebraic manipulation, we can transfer 63 to the other side. All right, so that we can isolate the variable x. This now becomes 68 minus 63 equal to half x, which gives us 5 equal to half x. Now take note, to solve for the x, we need to isolate it. So if we multiply this by 1/2, to cancel the half, we double this. Or we multiply this by 2. All right? Because half of x is simply like x divided by 2. So we do the reverse process. So we multiply this by 2 both sides. Therefore, x is equal to 10. Now, sorry, x is equal to 10. So if you try to look at it, for the total cost of 68, x indeed is 10 miles. And this is how useful it is once you have the equation. Okay? Let's try to practice coming up with linear equations. Suppose we have this particular graph. Okay? So first thing, find the slope. By now, you should already know how to get it because this is the previous activity. So slope is -2. And what's the meaning of this? Remember that any number has a denominator of 1. Therefore, we say temperature decreases because it's negative. Temperature decreases by how much? 2 degrees Fahrenheit. That's the change in the y per hour or every hour. That's the change in the x because this is 2 over 1. So change in x is 1. And then in the graph, you could also see that the y-intercept is 82 degrees Fahrenheit. This means that the initial or the starting temperature, even before time started um, to work, is already at 82, or temperature is starting, or the starting temperature is at 82 degrees Fahrenheit. Now, once we have this, we can now come up with our linear equation. We have y equal to, remember, slope times x plus y-intercept. Slope is -2, so -2 times x plus 82. And this is our linear equation. Again, once we have the linear equation, it's very easy to find values even beyond your graph. For instance, just to emphasize, what if time is 5 hours? So if it's 5 hours, that means this is the value of our x. Substituting it to the equation and solving for the value of y, we see that the temperature is 72 degrees Fahrenheit. Looking in the graph, 5 hours corresponds to 72 degrees Fahrenheit, which is correct. Also, if you are looking for the time at which temperature is at 78 degrees Fahrenheit, with the equation, we can now solve it. So this time, we substitute 78 to the y, and then we just simply solve. All right. Now take note here, we have -4 equal to -2x. To isolate the x, this is -2 times x. So we do the reverse operation. We divide both sides by -2. -4 over -2 gives you +2. Therefore, x is 2. So we can say temperature is at 78 degrees Fahrenheit when time is 2 hours. And this is how to come up with a linear equation. Now, what if you don't have a graph? What if you only have a table? So suppose we have a table of values. Let's try to recall, how do we find slope given table of values? Remember, first, of course, we need to know the x and the y quantities. So we already had this, no, in the previous video. So these are our x and y quantities. And for us to solve for the slope, we need to choose 2 points on the table of values, any 2 points. So let's choose these points. Then we find the change in the y, so current minus previous, divided by the change in the x, current minus previous. All right? So we now get change in y over change in x is just equal to this, all right, which gives us 20. Okay? So meaning, the encoder, it means that if you have a slope of 20 in this particular situation, this is 20 over 1. So the change in y is 20 words, and then the change in x is 1 minute. So we say the encoder can type 20 words every minute, or the number of words typed increases by 20 every minute. All right? So in this case, we know already that our slope is 20, and this is the interpretation. Question is, what is the y-intercept? How many words was he able to type at the start? Now, if you try to look at it, since we know that the encoder can type 20 words per minute, and in 3 minutes he was able to write 60 words, we can actually go backwards if you wanted to. That particular trick is very possible because 3x, which is x, no, in minutes, 3 minutes is very near 0 minutes. So it's easy to go backwards. For example, if in 3 minutes it's 60 words and we know it's 20 words per minute, so at 2 minutes this must be 40. At 1 minute this must be 20. At 0 minute it must be 0. Alright? However, what if the x value is far from 0? What if it's x is 200? Going backwards is not a practical thing. So there should be another way of finding the y-intercept without going backwards. And that's actually possible. How? This is how we are going to do it. So of course, currently, we know the slope, but we don't know the y-intercept. Again, we can find the slope by doing the previous strategy that we had. No? So you can replay and try to see how we were able to find the slope. So again, since we don't have the y-intercept, we can come up only with a partial linear equation. And our partial linear equation is just y equal to the slope times the x plus c, because we don't know the c. Okay? Now for us to solve the c, we need a value, just one pair of x and y. That's all we need. So in the table, you can choose any pair you'd like. Suppose we'll choose 3 and 60. So this is one pair. So we have one pair, another pair, this is another pair also. Let's just choose this particular number because it's small. So it's easy to manipulate if the numbers are small. So we'll choose this. So y is 60 when x is 3. So we are given at a certain point a value of y and a value of x. So we can actually use this, substitute this in our partial linear equation, so we can solve for the c. So take note, y is 60, so this y will just be 60, x is 3. So substituting it, we now have 60 equal to 20 times 3 plus c. So simplifying it, 20 times 3 is 60, and then isolating c, we transfer 60 to the other side. So c is equal to 60 minus 60. Indeed, c is 0, meaning at 0, there were no words encoded at the start, meaning at 0 minute, there were 0 words encoded. Okay? So since we now know our y-intercept, we can now complete the linear equation. Y equal to 20x plus 0, or we can just write it as y equal to 20x. And that's how to find the linear equation. Alright, by the way, this linear equation also models linear relationship. So the word is modeling. This will be my last example. So suppose we have this table of values. So find the slope in each of in this particular table. So here, the strategy, remember, we just choose 2 points and then find the change in the y and the change in the x. So we now have this previously. Therefore, here, this is actually our slope. This is actually our slope. So our slope is negative 5 over 3. So if you are confused, you can pause this video and you can study once again on how to find the slope. Now, suppose we already have found the slope. So this particular slope tells you that y quantity, since this is negative, decreases by 5 every 3 units increased in x. Every time you increase x by 3 units, y decreases by 5 units because this is negative. Okay? So the y-intercept is unknown. Again, we don't know the value of y when your x is 0. We don't know y when x is 0. So to do this, we can only do or write a partial linear equation. We have y equal to negative 5 thirds x plus c. So we know the slope, multiply it by x, but we don't know the c, the y-intercept. So again, to find the y-intercept, we need a certain point here. And you may choose any pairs of x and y that is given. I can choose the first, the second, the third, the fourth, and the fifth. I just want to choose this because this has a 0. And with a 0, it might be easier to compute it. Now, this is, you might be wondering, is this the y-intercept? Take note, y-intercept is defined as a certain value of y when x is 0. Here, y is 0 and x isn't. So this is not the y-intercept. Alright? Again, y-intercept is a value of y when x is 0. Here, x is not 0, the y is 0, but x isn't. So this is not the y-intercept. Conversely, we actually call this the x-intercept. But we will discuss that in some later time. For now, we are going to stick with y-intercept first. Again, I will use this certain value in order to solve for c. So here, y is 0 when x is 1. So we just have to substitute these values to y and x. Okay? And then manipulate, simplify. So isolate the c, transfer negative 5 thirds to the other side. C is equal to 5 thirds. Now we now have the value of c, so we can now complete the linear equation. So the partial equation can now be completed. We now have y equal to negative 5 thirds x plus 5 thirds. And that is how to find a linear equation. So this time, I'd like you now to do the green level activity. And please do help your other members, especially if they need help on this.